You will learn what a logical fallacy is. Next, you will familiarize yourself with examples of common fallacies. And finally, you will learn how to mitigate these fallacies by increasing awareness. A logical fallacy is a mistake in reasoning that weakens an argument. It happens when the logic used to support a conclusion is flawed, misleading, or invalid. Logical fallacies can cause us to accept claims that aren't really supported by evidence. Sometimes they're used intentionally to persuade or deceive, or often they arise from misunderstandings or biases. Understanding these fallacies helps you think more critically and evaluate arguments more effectively. A cognitive bias is a flaw in how our brain works. A logical fallacy is a flaw in the structure of an argument. Let's explore common logical fallacies and see how they could appear in computer science. Argumentum ad hominem is when you attack the person rather than the argument. For example, dismissing a developer's bug report by saying, "You are just a junior coder, so you must be wrong," instead of addressing the issue. False anomalies occur when important facts are left out to make a problem seem mysterious. For example, blaming a sudden system crash on a rare hardware fault while ignoring recent software updates that likely caused it. Argument by elimination is when you argue for one cause but ignore other possible explanations. For instance, saying a software slowdown is definitely due to a network without considering CPU overload or memory leaks. Illicit causal inference happens when correlation is mistaken for causation. For example, assuming that increased user error caused by new software features means the features are bad without checking if user training also changed. Unsupported analogies occur when a solution that worked in one context is wrongly applied to another. For example, assuming a security approach effective for desktop apps will work unchanged for mobile apps. Untestable explanations turn lack of evidence into proof. For example, claiming that a system is secure because no breaches have been reported, ignoring the possibility that attacks simply haven't been detected. Redundant prediction extends a theory without testing it. For example, saying, "Our algorithm is best because it follows known principles," without benchmarking it against alternatives. Finally, ad hoc rescues are excuses to save a falling theory. For instance, when a new bug appears, blaming it on unusual user behavior rather than examining possible flaws in the code. Red herring is when someone diverts attention from the real issue to something irrelevant. For example, in a code review, focusing on a developer's formatting style instead of addressing the critical security flaw in the code. Recognizing these fallacies helps you think critically and avoid poor reasoning in computer science. To reduce logical fallacies, the first step is also here: be aware, recognize common fallacies, and build strong critical thinking skills. Encourage evidence-based reasoning by requiring claims to be supported with clear, verifiable data, avoiding appeals to authority or emotion alone. Follow a stringent process. Example, the scientific method: observation, hypothesis, test, results, and conclusion. Use structured argumentation frameworks and promote peer reviews to catch and correct flaws reasoning early. This can be your colleague, supervisor, or peers if you stay in academia. Always consider alternative explanations and avoid jumping to conclusions without thorough analysis of potential alternatives. Be careful when claiming causality. Distinguish correlation from causation effect relationships by designing proper experiments or statistical tests. Promote transparency by sharing methods and data openly, inviting replication and critique. Register hypotheses, share your code and data. Finally, stay focused on the core issue, avoiding distractions of red herrings that divert attention from the real problem. Together, these practices help ensure clearer, stronger, and more reliable reasoning in your research and computing work. Logical fallacies are everywhere, in the news, politics, and social media, so it's important to stay vigilant. Be skeptical when you hear claims like, "Science has proven this." Always check the source and the method behind the claim. By questioning and critically evaluating information, you can avoid being misled and make better decisions in your research and work.